Recording. All right, we're going to start by going to the top that says combination. All right, so a combination is a selection of objects or people out of a possible total where order doesn't matter. Do you remember before we were talking about permutations where order matters? So it was like how many different ways can people line up at the door or something? Mm-hmm. Now it's more about who lined up at the door instead of how many different ways can they do it. Chevelle, like focus on me first and then destroying animals. Okay. A state's Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for a project. What does it mean when a place gets bids for a project?
Money.
What'd you say?
Money.
Money, but what does that mean by bids?
How much money that company owns the contract?
Right. So if a contractor says, we'll charge you $20,000 to get this done, and another contractor says, we'll charge you $19,000 to get this done, which one do you think they're going to go with? It depends. Are they going to go with the most expensive? Probably not. Are they going to go with the cheapest? I probably wouldn't also assume that. I'm guessing they'd go with someone on the cheaper end who's also very reliable, right? And if you have nobody who's reliable on the cheaper end, then maybe you're going to go more expensive because having work that's done well is more important than spending less money because ultimately you're going to end up spending more money in the long run if you have to keep getting it fixed. Okay, so how many different combinations of 4 companies can be selected from the 16 bidding companies? First of all, it says how many different combinations, so that's a big hint. But here, we don't care about the order in which they pick them. We just care about who they get.
Yeah.
Do you see what I'm saying? So this would be a combination. So what it would be is it would be 16 combination this time 4. Another formula for that would be 16 factorial on top. On the bottom, remember before it was 16 minus 4, which is 12 factorial. But then you would also divide by 4 factorial, which would be how many different ways you can order those 4 things. So these are the 2 different ways you can do it. You can either do it with this formula or that formula. We're going to try both right now. So everybody take out your calculator and put in 16 factorial. Where's the factorial symbol? Math. Over to probability, and then the 4th one.
Yep.
Divided by parentheses 12 factorial, 4 factorial. Hey Dylan, who's your partner?
What's your partner?
Yeah. Who?
Mine.
Chevelle, go sit by Dylan. Who's your partner?
Peyton.
Okay, who's your partner?
Trey.
Okay, I'm going to have you go sit with Dylan and Chevelle. Okay, sit with your group of 3 or group of 2, and then check each other on both of these. Show your partner that you can do both of these, that you can do 16 combination 4, and that you can do this stuff with the factorials, and if you can't do it, then ask them to show you where. What? So combination is exactly the same place that permutation is. You type in 16, then go to math, over to probability, down to the third option, NCR instead of NPR. and be 16 combination 4. So both of them should be 18, 20. Show your partner, like here's what I would show my partner. I'd show them that I can do the top one and I can do the bottom one. So show your partner that you could do that, and if you can't, have them show you where it is.
Lovely. Wow.
Dylan, are y'all good?
Yeah.
Chevelle, Casey? Good? And you two said you're good? All right, so everybody go down to the combination formula underneath here. It is NCR. On top of the formula is n factorial. On the bottom is n minus r factorial, and then an r factorial. I don't care if on example 2, if you do exactly using the NCR thing, or if you do the formula itself, but on example 2, try it with your partner, please.
Okay, so 20 and
Do you guys get 1,140? Did
yeah.
you say ew?
Yeah. What?
Okay. I'm just going to move on. I don't think I care that much. All right, so a student advisory board contains of 17 members. 3 members will serve as the board's secretary, chair, secretary, and webmaster. Each member is equally likely to serve into any of the positions. What is the probability of selecting at random the 3 members who currently hold the 3 positions? Okay. Does order matter in this problem?
Yes.
Yes, why?
Because it has like an extra.
An extra.
Like it's like 3 members who currently hold the 3 positions.
Oh, that's not why.
Oh. What was the question?
The question is this a permutation or a combination? Does order matter here? Do we care about who's in what spot?
Yes.
Yes.
Because of names.
Yes, and because it's literally different positions. If it just said 3 people doing 3 jobs, and they didn't explain what the jobs were,
It wouldn't matter.
then it wouldn't matter. It'd just be 3 people for the thing. But wouldn't you be upset? So the chair is like the president. Webmaster is the person who takes care of the website. And the secretary is the person who takes notes. If you're like, hey, I'd like to be the president of this club. And they're like, no problem. You're the secretary. And you're like, no, but I want to be president. And they're like, it doesn't matter. They're the same thing. They're not the same thing.
Yeah.
It'd be like voting for somebody and being like, hey, this person and this person are running for president and vice president. And you're like, cool. Which one's going to be president? And they're like, doesn't matter. We'll figure it out once they get voted in. We'll figure out who's president. Like, no, we do care about that. We care about which one's president. So this is permutation, and it says what's the probability of selecting at random the 3 members who currently hold the 3 positions. So this is going to be a fraction this time. On the bottom is going to be that there's 17 choices. And did you say a permutation or a combination?
Permutation.
So it's 17 permutation 3. And on the top, the chances of you getting it exactly right would be, there's only one chance of that, you getting it exactly right. So right now in your calculator, put in 7 permutation 3. Math probability. All right, so I got, you could write this or either one of this or this could be good answers. So when it says what are the chances, that's when you need to have like a division sign involved, a fraction involved. All right. Flip it over. After this lesson, and I give you a work day tomorrow, we're going to analyze poker and poker hands.
Do we get to play?
I would be okay with us playing one day after we do the math.
Okay.
So find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. All right, it says find the probability, so I'm putting down a division sign. Okay. On the bottom, this is going to be a very simple poker game where you don't get to switch any cards. It's just bluffing, saying what you think you got, okay? So you don't get to switch any cards. How many cards are in a deck? 52. And how many are we choosing? Is it a permutation or a combination? So here's what I mean by that. When you pick up the cards, are you allowed to move them around in your hand, or do you have to get them in exactly the order they came in?
You can move them around.
You can move them around. So it's a combination. All that matters is what you get, not what order you get them in. All right. Now we want them all to be diamonds, right? How many diamonds are in a deck?
13.
13. And how many do we want?
5.
5. And it doesn't matter what order we get them in. All right. So now in your calculator, do 13 choose 5. I got 0.000495. Did you guys get the same thing?
Yes.
You say no?
No, I said yeah.
Okay. Okay. Do you want my help with the next one, or do you want to try it with your team?
I can do it.
All right, why don't you try it?
So it's like the last one, but so when it says standard deck, is that including the jokers?
The standard deck does not have a joker in it already, so there'd be 54 cards now.
I got 0.000949.
Everybody feeling okay about this?
Yeah.
Okay. All right, a food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. Example 5 and example 6 are real life examples of how they use stats in production, where they need a test that will basically, they want to know how likely it is if they have a bad sample. If we pick 1 out of every 300 we get, how likely is it that we'll get a bad sample if there actually is some sampling? So, food manufacturers analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, they've already made it so that 3 kernels have dangerously high levels of the toxin, and then 3 out of 400, okay? And then they select randomly 4 kernels. What's the probability that exactly 1 kernel contains a dangerously high level of the toxin? Okay. So, first of all, does it matter what order they pick their corn kernels in? No. All right, so we're going to use combinations. How many corn kernels are there? 400. And we're selecting how many total? 4. And then, how many non-toxic ones do we want to get?
4.
It says
1.
we want 1 to be dangerous and the rest not.
1.
So, okay, well, let's do the dangerous ones first. How many ones are dangerous out of the 400?
3.
It says 4. You're right, 3 kernels are dangerous?
Yeah.
So 3 kernels are dangerous, and we want 1 of them. Times, how many are not dangerous?
397.
397, and how many of those do we want?
2.
3.
3 of them, because we want 4 total. So we want 4 total. We want 1 that's dangerous and 1 that's not dangerous. So go ahead and multiply these out. Did you guys get the same thing I did?
Yep.
All right. Do you want to try the last one with me or with your team?
Fine.
Okay, you guys try it.
Okay, so there's 12 numbers possible.
Talk to each other. If you're going to work as a group, then talk to each other.
And there's 5. And we want to so you see if you want 3. And then there's 5 men, 7 women. You want 2 women and then no, you want so you want then what we do is you see the
All right, a couple things to note. First of all, do you have to put the 7 choose 0 in there? Why?
Equals zero.
Well, it's not equal to 0. Anytime you use anything choose 0, the answer is 1. How many ways can I choose 0 of them? By not choosing anybody. That's one way I could do it. It's always going to be 1. So it's not going to affect anything else. Also, you can just think, I'm choosing 3 out of 5 men. I don't even need to talk about the women because I'm not choosing any of them, right? But if you look over here, you see that it equals 1. When would people use this in real life? This specific example. There are 5 men and 7 women on a jury, and then 3 jury members are selected at random for an interview. What's the chances that all 3 of them are men? Why would we use this in real life?
5.
Yeah. If you're saying, pretty weird that all 3 people who got interviewed happened to be men, and they're like, oh, it was random. Really? Because the chances of that is like 4%. So, I mean, it could happen, but it's pretty surprising that that would happen, right? And remember, anything that is labeled unusual probability is less than 5%. So often these kind of stats can be used to show whether somebody is truly being biased or having a sampling error, even if they're not aware of it. This homework is not due Friday. This is due Wednesday, though. So today you can use the rest of the time for your homework, and tomorrow you can use all your time for your homework. Yesterday or Friday, I gave you some problems from 174. I just picked the problems that you could do so far. So if you've worked on that assignment I gave you on Friday, you've just gotten part of this assignment done. Okay? Okay. Anybody want a copy of my notes? Dill?